recording. Okay. Has anybody heard of the words, I'm guessing you've heard of the word combination before. Have you heard of the word permutation before? Anybody know that you've heard of it, but do you know what it means? Anybody know what it means? Okay. So a permutation is how many ways something can be chosen when order matters. A good example is the warm-up over there. We care about the order, right? I mean, that was the whole question. The question is how many different orders are possible? How many different standings are possible? If I just said, hey, name the top 8 teams, we did it. It's already done. But I care about what order they're in, and that's a permutation. So permutation order matters. The formula for this is n factorial over n minus r factorial. And that is equal to NPR, which means that you have n like total objects or things, people, and this is how many you want. So for example, that problem over there would have been 8 permutation 8, because there are 8 teams, and I want to know the order of 8 teams. But if I just said, here are 8 teams, tell me how many different ways we could get the top 2 teams, that would be 8 permutation 2, because that's how many teams I actually want. All right, now, has anybody ever thought when they're looking at a Sudoku, like, how can there be so many different kinds of Sudoku puzzles? Like, this seems like they should have repeats eventually, right? Like there's books and books and books of Sudoku puzzles. Surely they have repeats. How many different ways can just the first row of a blank 9x9 Sudoku grid be filled? Okay, so is this a permutation? Does order matter in a Sudoku grid? Do we care what order the numbers go in? Yeah, we do. That's the point of a Sudoku puzzle, right? You've got to like put them in. If I just said, put the numbers anywhere you want, you get 100%. That'd be a pretty boring puzzle. The point of the puzzle, right, is to get them in exactly the right order. So order does matter in this case. That would be 9, permutation 9. I want to see how many different ways you can order 9 different numbers. You can think about this a few different ways. You can think about the way that you were thinking, or at least Caitlin and Ryan were thinking about the warm-up. By thinking, okay, the first spot has 9 choices, the second spot has 8 choices, 7, 6, 5, 4, 3, 2, 1. That would be 9 factorial. Or if you followed the formula, there are 9 choices, and we're dividing by 9 minus 9 factorial, which is 0, so it's still 9 factorial. So put in your calculator 9 factorial really quick. Or I guess if you'd really like to, you can write 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. If you did it right, you should have gotten 362,880. And that is how many different ways you could order the top row of a Sudoku puzzle. Just the top row. That's not the puzzle, that's just the top row. Do you imagine what a waste of time it would be if I was just like, list them all, right? If I was like, go ahead, just start listing them, right? I mean, that would take forever. Even if we all worked together, we'd probably die before we finished. Okay, let's try another one. Find the number of ways of forming 4-digit codes in which no digit is repeated. Okay, so how many digits are available? 10, including 0, right? And how many digits do we want? 4. We want 4. So this is going to be 10. Is this a permutation? Does order matter when you're typing in a code? Certainly does. You can't just be like, I think there was like a 5 in there and like a 2, a 3, and a 1. I don't know what order they're in, but those are the numbers. Like, you have to get them in order. That'd be 10 permutation 4. A few different ways you could do this. You could follow the formula and say that's a 10 factorial on top. On the bottom would be 10 minus 4 factorial, which is 6 factorial. So in your calculator, you could do 10 factorial divided by 6 factorial. Try it right now. Do 10 factorial divided by 6 factorial. Did you guys get 5,040? Another different way you can do this is there's actually a permutation button on your calculator. Okay, so am I jumping the gun? Is everybody at this point ready to go? Okay, so right now in your calculator, I want you just to type in 10. And then you're going to hit the math button. Go over to probability. Do you see the second one down says NPR? Hit that. 10 permutation 4. Okay, so that's even a faster way. If you're wondering where this formula comes from, because I'm guessing we probably have like maybe 2 or 3 people who would be interested in where this formula actually comes from, here's how. Remember how we used to do these problems? We'd have like 4 things, right? And how many options are there for the first spot? 10, and then 9, 8, and 7. You guys understand that? Now, if I had on top of a fraction 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 6 times 5 times 4 times 3 times 2 times 1, which is what 10 factorial divided by 6 factorial is. Do you see how it like gets rid of all the factorial parts that we don't need? That's where that formula comes from. It's saying that 10 minus 4, there's 6 things we don't need, so we want to cancel out 6 of them and just leave the stuff we need. So that's where that formula comes from. Go ahead and try example 3. I'll give you a prize. Yeah?
I have the answers.
Let's give everybody a shot, Gustavo. Gustavo's like, I'm already there. You can use the permutation button in your calculator. You can use factorials if you wish. Definitely use your calculator, though.